Okay, today in class we're going to be simplifying radicals, and some of these may have roots other than the square root, but we'll start with the square root just to show you, and then I'll show you an example from the homework. If we have the square root of 196 x times y, remember that according to our square root properties, you can actually separate this into the square root of 196 times the square root of x times the square root of y. Well, 196 is a perfect square. The square root is 14. And now, x and y, neither one are perfect squares, and they have no factors that are perfect squares, so we leave them underneath the radical just exactly like they are, and we're finished. Now, if you look at this example, the square root of 8 times x squared, 8 is not a perfect square, but we could write 8 as 4 times 2, and 4 is a perfect square. So, simplifying just the square root of 8, okay, if we split that into 4 times 2, then we take the square root of 4, okay, which is 2, bring that outside the radical, leave the 2 under the radical, and the square root of x squared is just x. Okay, remember in these cases, if you'd like, you can write this as a x to a fractional exponent. So this would be x to the 2 over 2 power, which is just x to the first power, or x. Alright, let me show you an example from today's assignment, taking a different root other than a square root. Alright, y'all, let's look at number 15. We're taking the cube root of negative 64, r to the second power, w to the 15th power. Okay, if we rewrite this as the cube root of negative 64, okay, the cube root of r squared, and the cube root of w to the 15th power. The cube root of negative 64 is negative 4. Okay, the cube root, and I'm going to go to this one next because I can actually see that this is going to be a perfect cube. The cube root of w to the 15th would be w to the 5th, because we could write that as w to the 15 over 3. Now, so r squared, 2 does not divide evenly by 3, so we leave the r squared under the radical and have the cube root. So this would be our final simplification.